Say it one more time.
An angle and a circle with a vertex at the center.
Okay.
And
So,
and endpoints on the circle.
and endpoints on the circle. Exactly right. So from there, then we looked at that central angle formed two arcs, right? We had a minor arc and a major arc. A minor arc would have been considered where?
The small,
Less than
180.
Less than 180 or inside the endpoints of that central angle, right? And then a major arc would have been obviously to the opposite side, and we said that a major arc should be over what? 180 degrees, okay? And then a couple things that we came up with in the other class was, yesterday we said that a major arc should always have how many letters? 3. And that usually a minor arc only had what? 2. The 2 endpoints of that central angle, okay? Don't be confused if this happens though. So sometimes they'll give you a central angle, and yes, if they call this SK, that's my minor arc. But if they put a point right here and call it T, and they call it STK and put an arc over, it's still a minor arc because I'm going from STK. So just because there's 3 letters, don't automatically jump to the conclusion that it's a major arc. But with the letters, you got to make sure that you're going in that order. So when they put another dot over here and call this R, if they call this KRS, I have to go in that order. Alright? So you just got to make sure that you follow the letters how they are. So yesterday we said that major arcs had 3 letters, but a minor arc could actually have 3 letters and it'd still be a minor, not a major. Okay? What else was true about that central angle and the minor arc?
That's, the 2 angles should be equal to the central angle. If that makes any sense.
It was less than 180.
What is true about the central angle and the minor arc?
They're equal in degrees.
They're equal in measures, right? Degrees. Remember, anytime we're talking about measures, we're talking about degrees.
How do you tell which one's your central angle and which one's your minor arc, like in that?
My central angle and my minor arc go together. So if this is circle, what do I have? P, my central angle is SPK, my minor arc is SK.
So can you tell me which one is your central angle and which one's your minor arc in that one?
There's a lot of them.
So any
RTS, RTS, and RS go together.
QTR.
RTS is my central angle,
Yeah.
and RS is my minor arc.
And so
They go together.
your minor arc and central angle are equal in degrees.
Equal in degrees. They're the same measure.
So
But
then what's
it's
the
a-
difference?
It's a side, but I thought the arc was like this, part of the circumference. So how can that be
It's-
measured?
But it's the degree measure of the arc. So it's the degree measure of 360 degrees. That's how much that arc is in degrees. But there's also a length of that. How much it is of 360 degrees is different than the length of it.
Okay, and so I could say any of those, like if you ask me for a central angle and a minor arc, I could say STU and SU.
Yes,
And
ma'am.
every single one, even
Every single one.
RV, I meant QV.
QTV
Yeah.
and QV.
So every single angle and arc is a central.
Not necessarily, no.
Central angle.
Because if I was looking at QTV, the other side of it, okay? So when I say QTV, you see QTV over here, right? QTV,
Yeah.
you're looking at this one, but let's say QTV on this side. This right here, if I'm looking at this arc right here, then I know that's a major arc. So if I would say QSV, that's a major arc because I'm going around the right-hand side. So I'm starting at Q and going to QSV.
Okay. But like is QTV a central angle?
QTV is a central angle with QV as its minor arc.
Lit. Okay. Good.
We're crystal now?
Yeah.
Okay. What was the next thing we talked about? Adjacent angles or adjacent arcs. And the adjacent arcs could lead us to arc addition. And then we kind of hit on the difference between measures and lengths, right? If we're talking about a length, we had a formula. What was that formula? Times basically circumference, right? So you can use 2 pi r, or you could use what here? Pi times diameter. And again, you'll see here when you're going to do some of your problems at the end that it makes a difference if you use pi or if you use 3.14. But again, I will do it both ways, so you can do it however you want. Okay? All right. Anything else that we forgot to talk about? So here we go. Find the value of x. How the heck do I do it? Let everybody have a chance to think. If you can't see, you got to just move up closer. That's as big as I can make it.
Is R
Okay, this is a great question right here. Right? Did everybody hear what I said? Is RV a diameter? So does it look like it? Remember how I've stressed you cannot just look at a shape and say something about it? In this case right here, if they don't say it's a diameter, and there's no number proof that says it's not, then you have to assume that it is. So yes, in this case it would be. So realistically, when they said find the value of x, they should have really said RV is a diameter. Okay? In my personal opinion. But they didn't. Okay, so everybody have a plan? To find x. What do you got?
Since all of those, like RV is a diameter, so it cuts the circle in half, so it's also a semicircle, so you say all is equal to 1/8.
Exactly right. So we're going to do this right here, right? Okay? So here's a question. Don't say anything out loud. Let everybody think. Are QTR and VTU vertical angles?
Yes. Yes.
No.
No.
Yes, it
Because the one line is not straight across.
Oh, yeah, I guess so. If it was, then it was.
Oh.
What? So would everybody agree no? So here's the next question. Are there any vertical angles in that picture? Or that figure?
That's the question.
No, there's not.
No, there's not.
No.
I would agree. Okay? Here's the next question. Can I find every single angle?
Yes.
Even QTR?
No.
Yes.
Nope.
Why do you say no?
Yep.
Why do you say yep?
Because you have x and then you can just subtract it from 180.
Perfect. Exactly right. Mac.
I was gonna ask, what's your major arc and what's your minor arc when you like use a diameter to cut it in half?
Then on a semicircle, you wouldn't have a major and a minor. Because they would basically both be the same thing.
Yeah.
It's a good question. Okay? Now, what happens if I said, oh, I erased it. Anybody do the math? What's x? 7. Okay, so here's the question. Just think, don't say it out loud. What is the measure of arc SU? Everybody understand? Everybody got a plan? Right? Simple math?
Did you say RU?
SU.
Oh.
Right? Simple math?
I don't know what I'm supposed to use.
What are we supposed to use? for the measure of. Put it in for what? Put it in for 13x minus 3. So take 13 times 7 minus 3. 88. That's my answer.
For SU.
For the measure of the arc SU, not the length. Okay? If they say the length, then we would have done this. Then we would have taken that 88 and put it right here. But we can't do that problem right there because why? We don't know what either the diameter length is or the radius length is. Okay? Pretty cool problem, right? Any questions? This section actually has really good problems. I'm very happy with them. Here we go. Read it first. What's the most important part of this problem that I've said in this whole chapter?
It is circles.
Read the directions and follow the directions for every single section. Make sure you understand, one, what they are asking for, and two, that you answer the question. So on that last problem, it said find x, right? You're done. But if it said find x and, obviously you need two answers then. Or you need multiple answers. So make sure you have the same number of answers. All right, here we go. Everybody got it? Everybody got a plan? WC is a radius of circle C. So again, in my personal opinion, they should have said what?
XY is diameter.
They should have told you that XY was a diameter. If they didn't tell you that, then we could have actual arguments, right? So Riley says, I think WCY is 89 degrees. Could be, right? If they specifically don't say that that's a diameter. Even with the box, right? You see what I'm saying? So, again, because they don't tell you and there's nothing that mathematically would prove that it's not, then you have to assume that it is. So what I'm saying is, in the book, you'll see this when we do our problems at the end, they tell you that WCY is 85 degrees, but it looks just like that. So if they tell you that it's 85 degrees, you have to go with it. You can't say, no, it looks straight to me, I'm going to say that's 90 degrees. That makes sense? Okay, so let's go back to the question. Identify X, Z, Y. So again, I got to go in that order. So don't go left, go right, right? X, Z, Y. So we would call it a what? Semicircle. And what's its arc then? 180 degrees, right? Okay. What is the measure of the arc WY? 90. As long as we assume that it's a right angle, right? Or a diameter, sorry. Everybody okay there?
Yeah.
What do you think? Minor arc, major arc, or semicircle?
How come it says identical? Oh.
What did we say?
A.
A, minor arc, and 90 degrees. Don't forget, if you don't put the little M out in front, then you have to have what over here?
Degrees.
The degree symbol. Perfect. So the next one, we kind of talked about a little bit yesterday, but I know it's kind of hard to see you with the different colors. But this one says, refer to the circle graph and then find the measure of KL. Anytime it has that M in front, that automatically tells you you're looking for a what? A degree. So what's the measure of arc KL? So first thing first, we got to find KL, right? So KL is the what section?
Comfort.
Yeah.
The orange section, the comfort section. What did she say? So it says that piece of the pie or the circle is 21%.
360 times 0.21.
Oh, I thought you already did it.
Oh, no. I'm just proud of that part.
So punch in your calculator, what do we get?
75.6 degrees.
75.6 degrees. Make sure then you read the directions to see what you're supposed to round to, and don't forget your degree symbol, but you're exactly right. 0.21, so whatever percentage they give me, times 360 degrees, because it's all the way around. Right? Remember, now we're asking what's that arc percentage as a degree. So we're still not into this. What?
Why is that 0.21?
How are you going to do 21% otherwise?
But
You're going to do 21 divided by 100 times 360. So the same difference is
times
21 divided by 100.
It's
Is
like
all-
over of,
oh, so anytime you put it in, you have to make sure it's not a full number first.
you're just making a decimal out of the percentage.
A percent is always based off of what? What is your grade based off of? 100%. So if you have 21% of that,
Oh, so that's why it's 0.21.
yeah, because you divide by 100. And that means you move the decimal place 2 places. To the left. This is why we don't take your class very often. So then we go to arc addition. Okay, we had some interesting answers in the other class for this one. That is an I. So, can I find the measure of LHI?
Yes.
Yes.
Let everybody think for a second.
They obviously can't watch this video.
Yeah.
What?
You obviously can. What else could you do?
Unless LJ is not a diameter.
Right. So here again, because they don't say it, they really should. I personally believe that they should have told you LJ is a diameter, right? So this one's easy, right? How much?
58.
No. LHI,
90.
Oh.
right? So what was 58? LMH, the angle, or it was LH, the arc.
So you're telling me if you took 0.58 divided by 360, then times it times 2 pi r, you would get 90 degrees?
No, that's blank.
Oh.
That's the length.
Oh, yeah.
Okay, so here's the next question. Don't say this one out loud, let everybody think. Do I have vertical angles in this?
Yeah.
You're supposed to be thinking. Why can we say there are vertical angles in this one and we couldn't in the other one?
Because there's
Two
two
diameters.
There's 2 diameters. Perfect. So here's the next question. Don't say it out loud, let everybody have a chance to think. Are HMJ and LMK vertical angles?
Yeah.
Are they?
Wait.
Yes. If the 2 little ones this way are, right? If these 2 are vertical, then HMJ has to be vertical to LMK.
H and what? HMJ.
He just outlined it with his marker. He's putting red on it.
There's vertical?
Those are vertical angles.
How?
Because that.
Oh, yeah, I know the vertical. Yeah.
They're
I
crossed.
thought you were talking about perpendicular.
No.
Yeah, now I was confused.
He's got to sit over here from now on.
Everybody good?
Yeah. The language is really good.
Yeah, you might have to get away from Sammy for a little bit.
Me and Austin can trade places.
Alright, so now you gotta be careful, right? Find the length of DA round to the nearest 100. So again, this one's not as big of a deal unless, instead of them saying find DA, if they told you to find DC, then you would have to honestly know that AC is a diameter, right? But they don't do that in this case. They just ask you to find AD. So now what are we going to use?
That little equation.
This right here, right? So 40 over 360 times 2 pi 4.5.
Isn't it 0.4 over 360?
No.
I thought you said you had to do that every time.
you're doing two different kinds of problems. You're doing two.
That's still just
Hold on.
It's not.
When they asked you in the previous one, they gave you a whole circle,
Oh, I got that.
and they asked you what percent was the measure of the arc.
Oh.
This one's asking you for the length of the arc. It's an actual distance.
So in that one, you didn't have to take 0.21 over 360 then, did you?
No,
Oh,
I'm
okay,
using 40 right here.
That's like the whole way out.
Right, right. Okay, so here's the other thing. If you're going to punch this into your calculator and you're going to try to just do it all at one time, you probably need to have your fraction in parentheses. So put parentheses 40 over 360 parentheses and then times 2 pi and your number. So what'd you come up with? Anybody do it?
Yeah.
3.1459.
No.
That's what he got.
That's what I got.
I don't think so. Unless the other class was telling me wrong.
You think 40 divided by 360?
Oh,
Yeah.
1.15. You're right.
Don't tell me I'm wrong again.
Excuse me? I will. Then the other class lied to me. Oh! Here's the other thing I want to make sure of. Remember this right here. Because it's a length now, don't forget that you have to have centimeters on it. Okay? That you have to have centimeters on it. Okay? And then the only other one I wanted to show you was this. So again, if they ask you to do this problem right here, but I'm changing the directions here, and I want you to find the length of, oh no, this is perfect, JL. So the first thing that I have to do is what?
Assume that
Figure out what
3K is
the
the diameter.
measure of
I gotta assume that it's a diameter, so then what?
Find the angles between
180 divided by 1.
180 minus 22 first, and then use that degree in my formula. Okay? Everybody agree? You understand that one? Okay? Questions? Okay, now here's your two options. We still got a lot of time left today. You got about 15 minutes. So your options are this. You either go through these problems, and I know if you're not going to do the homework, that's fine. But you got to go through the